Good day everybody. I am Kuruppu Achchige. This is the second video of my final year project. In this video, we are going to discuss the methodology, technologies that are going to be used in this project, placement of sensors, and finally, how the system is working. An array of sensors are connected with the microcontroller. Here are some sensors attached to the backpack. Gyro sensors to monitor moving angles of the spine, muscle sensors to measure muscle compression and movements, force sensors to measure the force on shoulders when the user is carrying the backpack, and the weight sensor to measure the weight inside the bag. Data is sent to the user over the internet by storing those data in a cloud system. Before the user receiving the information, the raw data given by the sensors is processed by the Arduino and the cloud system to generate reliable information to the user. Processed data is provided through a mobile application to the user. Through this system, I am going to use the Arduino platform, which is an open source electronic platform. Various kind of microcontrollers are used with a variety of boards. User-friendly C-based language is used for programming. Programmable with the Arduino IDE. Many sensors are compatible with Arduino boards nowadays. This is another module that is going to be used in this system, which is known as ESP8266 Wi-Fi module. This module is connected with the microcontroller to enable the connectivity between the developing device and the Wi-Fi router. The capability of sending data over the internet is provided by this module. Here are some capabilities of this module. 2.4 GHz Wi-Fi, general purpose input output, inter-integrated circuit, serial communication protocol, analog to digital conversion, and it has a 10-bit analog to digital converter, serial peripheral interface, serial communication protocol, I2S interfaces with DMA, direct memory access, uh, pulse width modulation, which is a modulation technique. Uh, this module is mostly used for development of IoT embedded applications nowadays. MPU 6050 module is another module that is going to be used. This module has 3-axis gyroscope sensor as well as a 3-axis accelerometer sensor and the digital motion processor all together in one module. As an additional feature, this module has on-chip temperature sensor as well as I2C bus interface to communicate with the microcontroller and the auxiliary I2C bus to communicate with other sensor devices. I am planning to mount this sensor on the backpack to monitor the angles and the movements of the spine. Other sensors that I am going to use are myovea muscle sensor, weight sensor, and Arduino compatible force sensors. Technologies. Wi-Fi technology is used for wireless communication, which enables the data transmission between the device and the cloud storage. All the sensor data are processed in the microcontroller, and those data are transmitted to the cloud to store on the cloud storage, and then the user can access those data through the internet. Second one is cloud services. There are many cloud services that works with IoT implementations nowadays. In this project, I am using Microsoft Azure IoT suite for this project. A cloud storage. Cloud storage is a cloud computing model in which data is stored on remote servers accessed from the internet. Uh, Another one is mobile application development technologies. Uh, in this project, I am going to use Android Studio for developing mobile applications. Uh, Java is the official language for developing applications by using this Android Studio, but C++ also can be used with Android Native Development Kit. This mobile application is used to improve the interaction between the user and the backpack. Placement of sensors. Sensors are placed for detecting related body parts, upper back spine, muscles on chest and shoulders. As shown in this figure, affected body areas. These are the body areas that are affected due to the carrying of heavy backpacks. Muscles on chest, shoulders and the spine. We can see that from this figure, uh, these body areas directly attach with the backpack when a child is uh, wearing the bag. So these are the body areas highly susceptible for injuries due to the heavy weight inside the backpack. Arduino board and the controller is mounted uh, inside the bag while the sensors are mounted outside the bag. As shown in this figure, placement of sensors. Uh, the Arduino plus Wi-Fi module, which is the device is mounted inside the backpack, and the sensors are mounted outside. Uh, as shown in this figure, a flexible metal bar is used. This flexible metal bar uh, is used to have a similar movement of the spine. As an example, when the spine is uh, bent forward, this flexible metal bar should bend forward as same as the spine. So here on the flexible metal bar, uh, the gyro sensor and the accelerometer sensor module is placed here to measure the angles of this uh, metal bar when moving here and there. So the flexibility of this metal bar should be compatible with the flexibility of movement of the real human spine. Uh, so this is a big challenge in this proposed system uh, to have the uh, actual movement of the spine through this flexible metal bar. Uh, when we consider other sensors, here here the muscle sensors are placed to measure the muscle compressions, and here the force sensors are placed to measure the force on shoulders due to the weight of the backpack. Working of the system. Sensors mounted on the backpack monitor movements of related body areas. Then the sensor data is categorized and processed a wireless connection with the help of a Wi-Fi module and stored in the cloud database. Uh,
Then those stored categorized data is further processed in the cloud system, uh, and those uh, information is stored in the cloud system as the reliable information which is usable by the user.
Then the user will connect to the internet through the mobile application for accessing information in the cloud storage. Those informations are accessed by the user through nice interfaces, attractive interfaces of the mobile application. Uh, so all based on all the reliable information gained by the user will take necessary actions uh, to avoid from the spinal injuries, muscle strains that he or she will have to face in the near future. This is the system overview. As we discussed in the previous slide, uh, this backpack has the sensor, Arduino board plus Wi-Fi module attached on the backpack. This backpack connects with the Wi-Fi router with the help of the Wi-Fi module, uh, and all the physical changes of body areas affected by the heavy weight of the backpack uh, is uh, captured through the sensors, and those sensor data will be transmitted to the Wi-Fi router, and then the Wi-Fi router will transmit those data to the cloud storage. Then the cloud storage will process those data further to generate reliable information to the user. Then the user connects to the internet with uh, the mobile application for accessing those reliable information. So as the final outcome of the system, the user will be provided with some alerts, warnings, predictions about diseases, and workouts which should be followed by the user, and take some necessary actions to uh, abstain from the spinal injuries that the user will face in the near or far future.
Proposed testing. In this proposed testing, gathering and processing of sensor data is implemented by the Arduino board. MPU6050 module is responsible to measure angles when the spine is being bent. A threshold value is introduced to the system which the spine exceeds by bending forward will result in negative effects. Similarly, for muscle sensor, pressure sensor and weight sensor, a threshold value is going to be introduced. So the physical changes are going to be measured through sensors and compared with threshold values. If threshold values are exceeded when the user carrying the backpack, the user will inform about the condition through the mobile application. So the reliability of data provided by the system is tested with the help of threshold values and the information of research papers. Also, the system is going to be tested by using two school students between the age of 11 and 15. The natural S shape of the spine can be changed within 2 or 3 months by carrying heavy backpacks day by day. Therefore, from both students, one will be a student who has been carrying a heavy school backpack for 3 months, while the other student will be carrying the developed backpack during that period. After 3 months or 4 months duration, the two students will be interviewed and checked for any changes in their spinal shapes or musculoskeletal problems to test whether the developed backpack is successful to reduce the burden of heavy school bags of students.
So this is the end of my second video. The next video will cover about the progress of my project. Thank you for listening. See you all soon.